Hello, everyone. Welcome back. Today, we're going to talk about adding and subtracting radicals. We're going to start with some simpler ones, and then we are going to get into some more challenging ones as we go along as well. So let's dive in. Okay, so this first question says root 7 plus 3 root 7. So if we have 1 root 7 plus 3 root 7, overall we have 4 root 7, right? So the way we answer this is very similar to the way we would collect like terms when we have variables, that sort of thing. The only difference is these aren't variables, right? They're radicals. And then similarly with number 2, we have 3 times the cube root of 16 plus 5 times the cube root of 16. So overall that's going to be 8 times the cube root of 16, like that. Okay. So the next thing we're going to do here, oh, and actually I'm just noticing with this one here, this is not actually in simplest form because 16 does have a perfect cube that is a factor of it, right? As we know, 2 cubed is equal to 8, and that is a factor of 16. So I'm going to simplify this further by rewriting this as cube root of 8 times 2, which is going to be, let's see, 8 times 2 times root 2. And that's going to give me 16 times cube root of 2, like that. All right, so there's those first two. Let's try number 3. So number 3 says fifth root of 32 minus 4 times fifth root of 2. So for this one, the fifth root of 32 is actually 2 itself, right? Because 2 to the power of 5 is 32. So I'm going to rewrite this as 2 minus 4 times the fifth root of 2. And that's actually all we can do to simplify this. We can't do anything further to fully immerse these, unfortunately, without just going into decimal numbers. So this is all we can do for this one. For number 4, we have 7 root 20 plus root 45. So first thing I'm going to do is I'm going to see, is there a possible way that we can get these numbers to both have the same root? Because that's the only way we can actually add or subtract these and integrate them together is if they're the same root. And so the first thing I'm going to do is figure out, is there any way we can simplify each one? So starting with 20, can we simplify 20 in any way? Well, the thing is that 2 squared is 4, right? 2 squared is 4, and 4 is a factor of 20. Okay, so we can first say that this is equal to 7 times the square root of 4 times 5. We can do the same for 45, right? I know that 3 squared is equal to 9, and 9 times 5 is 45. And then for our next step, we can say, well, this is the same as 7 times root 4 times root 5 plus root 9 times root 5. So then we have 7 times 2 times root 5 plus 3 times root 5. And then 7 times 2 is just 14. So this is 14 root 5 plus 3 root 5. And then this is just 17 root 5, like that. And so the key here is see if we can simplify these far enough that we end up getting the same root. Now, sometimes we're just not going to get the same root, and there's only so much we can do. But oftentimes in practice with questions like this, we usually will. Let's try one last one for today. Here we have 2 root 50 plus root 8. Now, both 50 and root 8 have at least one factor that is a perfect square. So for 50, let's start with that one. We know that 5 squared is 25, and that is a factor of 50. So let's do that. 25 times 2. And then for root 8, we know that 2 squared is 4, and that 4 is a factor of 8. So this is the same as square root of 4 times 2. And then we can say Well, then this is the same as 2 times root 25 times root 2 plus root 4 times root 2, right? We can separate those. And then square root of 25 is 5. So this is just 2 times 5 root 2. And then plus 2 root 2, since square root of 4 is 2. Then we can multiply the 5 and the 2 to get 10 root 2 plus 2 root 2, giving us 12 root 2 as our final answer there. As always, feel free to write any questions you might have in the comments, and we'll see you for the next one.